Welcome. In this particular video, we'll be using the law of cosines in order to find sides in a triangle. So let's go ahead and take a look at our example. Find length BC, round your answer to the nearest tenth. So we're looking for the length BC. The first thing I always recommend you do is let's go ahead and label the sides. So remember, the side across from angle A is what we refer to as side lowercase a. The side across from your angle B is what we refer to as side lowercase b. And the side across from your angle C is what we refer to as side lowercase c. Now our ultimate goal is to find the length BC. So let's write it down. Our goal is to find length BC. But BC is the length of this line segment. It's actually A. Okay, so we're looking for A. Now, looking at the law of cosines, and why do we know this is a case for the law of cosines? Well, it's because what you're given is a side, an angle, and then the side. Okay, so we're going to look at the different statements of the law of cosines, and specifically we want to be able to find A, so we're going to look for the one that allows us to figure out what is the value for A. In this particular case, notice the first statement comes along with its equivalent statement, and the second statement along with its equivalent statement, and so forth. So here we can see that since we already have a squared here on the left hand side, this might be ideal for us. So let's go ahead and use this first statement of the law of cosine. So we have a squared is equal to b squared plus c squared minus 2 times b times c times cosine of A. Once we have that, I always suggest that we substitute in what we already know. We don't know what A squared is. In fact, we're looking for A, so we're going to just leave it as A squared is equal to B squared. Okay, well, B is 19. B squared will be 19 squared. Plus a C squared, well, C is 24, so C squared will be 24 squared. Minus 2 times B, which we said was 19, times C, which we said was 24, times the cosine of angle A. And notice, angle A has a measure of 131 degrees, so we have the cosine of 131 degrees. Now, notice that this is equal to A squared. So we have an equation in which we have A squared. Our ultimate goal is to get the A by itself, so what we're going to do, we're going to take the square root on both sides of the equation here in order to ensure equality. And we're going to get that A, it's simply equal to the square root of 19 squared plus 24 squared minus 2 times 19 times 24 times cosine of 131 degrees. Now this is what we call the exact solution. But notice, they are asking us to round our answer to the nearest tenth. So what we want to do is to get an approximation, and for us to get that approximation, we're going to be using the technology. In my case, I'm going to be using the TI Inspire. So let's go ahead and take a look at the Inspire real quick, and let's go ahead and take the square root. So I'm going to need the square root. Square root is here in blue, so I need to hit control first, so control x squared, and then we're going to have 19 squared plus 24 squared, then minus 2 times 19 times 24 times the cosine. Let me go here under trig, cosine of 131 degrees. Close the parentheses. Now before I do anything, I need to make sure that I'm in the right window with the right format. In this case, I want my format to be in degree mode. Okay. Now, the Inspire, if I were to just hit enter right now, it would just give me the equivalent or the exact solution. So since I'm looking for an approximation, I need to hit control enter. And notice that gives me 39.1832. However, since I need to get to the nearest tenth, I'm going to go to this particular digit, and since the following it's one of the higher values, I'm going to round up to 39.2. Okay, so going back to the problem here, I'm going to say that A is approximately 39.2 feet. However, that was not the original question that they were asking. They were asking us for length. So we can say, therefore, the length BC is about or approximately 39.2 feet. Okay. And why can we make this connection? Well, we can make this connection because the length of BC is the same as A. Okay. So that concludes this particular example where we were using the law of cosines in order to find missing lengths in a triangle. So I thank you for watching, and I wish you a wonderful day.